Coordinate geometry, working out the gradient of a line. To work out the gradient of a line, you need the coordinates of 2 points on the line. So we have the change in the y-coordinates, represented by this length here, and the change in the x-coordinates, represented by this length here. And we know that the gradient of a line is just the change in y divided by the change in x. So this is a basic formula. The change in y divided by change in x, a basic formula giving you the gradient of a line. So there's nothing new here. This is probably something that you've done many times before. Okay, let's have a look at this example. We've got this line here. These 2 points and their coordinates are given. To work out the gradient, we need the change in y. So starting with this point, 9 minus 3, divided by the change in x, 4 minus 2. So again, starting from this point again, so starting with the 4 minus 2, which gives a gradient of 3. An alternative way would have been to start with this point. So if we're doing the change in y, it's 3 minus 9 divided by the change in x, so that's 2 minus 4. And if we do 3 minus 9, we get minus 6. 2 minus 4 gives minus 2. 6 divided by 2 is 3, and if you divide two negative numbers, you get a positive number. Exactly the same gradient. Another example, we have 2 points again. So let's say if I start with point B, so change in y, so 5 minus 1, so be careful with the signs, divided by the change in x, so starting with B again, 3 minus the x-coordinate here, minus 2. So that's 5 plus 1, 3 plus 2. So this is the gradient of the line that goes through points A and B. What you'll find is that in most instances, it's better to leave the gradient that's in a top-heavy fractional format like this, or as an improper fraction. It's better to leave it in this form rather than say, well, this is the same as 1 and 1/5. Because the typical next step would be to write down the equation of the line that goes through points A and B, and to write down the equation of a line, what you'll find is that this form is more useful than this. To work out the gradient of the line that goes through these 2 points, change in y divided by the change in x. So this time, let's start with point A. So 5 minus 2 divided by change in x, 1 minus 6. 5 minus 2 is 3 over 1 minus 6 is minus 5. Now what you'll find is that 3 over minus 5 as a fraction is exactly the same as minus 3/5, which is exactly the same as minus 3 over 5. And in all of these fractions here, this is useful, to have the minus in the front. Example 4, starting with point B this time. So the change in y, 5 minus 5 divided by the change in x. So starting with B again, 6 minus 1. So that's 5 minus 5 is 0, 6 minus 1 is 5. 0 divided by anything is always 0. So the line that goes through points A and B has a gradient of 0, which means the line is horizontal. It's horizontal because the y-coordinates of both points is the same. So you would have point A 1, 5, so that's point A there. Point B 6, 5. 6, 5, there, point B. And the line that goes through these points is a horizontal line. Horizontal lines always have a gradient of 0. In this example, we can see that the x-coordinates this time are the same for both A and B. So to work out the gradient of the line that goes through A and B, if I start with point B, so the change in y, 8 minus 2, divided by the change in x, 6 minus 6. So 8 minus 2 gives me 6. 6 minus 6 is 0. Anything divided by 0 is undefined, meaning that it's infinitely large. And this is the symbol for infinity. It's like the number 8, but instead of being vertical, it's horizontal. So what does that mean then if a gradient is undefined? Let's have a look at this graphically. The point A, coordinates 6. So let's say that's 6 there, and that's 2. So this is point A. And point B, coordinates 6, 8. So let's say this is point B. Then the line that goes through these two is vertical. So vertical lines always have a gradient that's undefined. It's infinitely large. So a vertical line has a gradient that's undefined. A horizontal line has a gradient that's 0. Lines sloping like this have a positive gradient, and lines sloping like this have a negative gradient.